Assalamu alaikum everyone. This is your instructor, engineer Ibad, and I hope everyone is doing well. Please be safe and be at home. Anyways, today we will start our next lab that is based on the topic of threads. That is threads creation and execution. You can find this in the lab manual as lab number 7, and it's named as threads creation and execution. Okay, well, you must have studied in your theory that what threads are, how do they work, and how are they created, and how are they exited, and other properties. So what's the objective of this lab? This lab examines aspects of threads and multiprocessing or multi-threading. The primary objective of this lab is to implement the thread management. Okay, so basically what is a thread? A thread is basically a semi-process that is its own stack and executes a given piece of code. What is the main objective of this lab in simple words? It's that we should know about the thread IDs. We should know that what's the difference between threading and parent-child processes, and what about the data management in threads, and then what's the difference basically what is the difference between the data management between parent and child processes and in threads. So I must say that you people should go through the lab manual before attempting the lab, because there are many important points in the lab manual before you should do it practically. All right. Okay, so the API that we will be using is known as pthreads in Linux, and the subroutines which comprise the pthreads API can be informally grouped into three major classes: thread management, mutexes, and condition variables. In this lab we have to focus on thread management. So this thread management it covers creating, detaching, joining, etc. of threading. Then mutexes is, in simple words, is basically locks that we do not want to risk the data reading and writing. So there are many different problems that you'll be covering later. So we have to put a lock on one process or one thread, and then after that we if one thread or one process has not been executed fully, so we should lock the thread or the process, and once it has executed completely, then we have to move to the other one. So mutexes are basically those locks. We will cover it later. Then conditional variables, again we will cover it later. This is just a side note that the naming convention of the pre-thread API that we'll be using, that every identifier begins with the name pthread underscore, like pthread underscore attribute, mutex, condition, keys, etc. Okay, so what core things are in thread management? So the functions like pthread create, pthread exit, and pthread join. These are really three simple three functions of thread management. The first one is pthread create. It is, as the name indicates, it is used for the creation of a thread. Then pthread exit, again it is used to terminate a thread. So a thread basically a thread terminates its own self. Then the function pthread join is used by a thread to wait for termination of another thread. It is basically pthread join. You can call it as a waiting function of threads, right? So these are the different. You must just go through it. These are the properties of how do you call these functions, like pthread create. These are its parameters. Then pthread exit. These are its parameters. Here we will just use null in this lab. Then pthread join, again we'll just use a null here, but these are the parameters given. Okay, well, if a thread is created successfully, it should return a value of 0. If not, then it will return an error code, right? So if you want to check that whether a thread has been created or not, you should check it by using the return value, that is 0. Then again in pthread exit, the return value is passed as a pointer. This pointer value can be anything so long that it does not exceed the size of, alright, okay, so we'll just be using a null over here, don't worry about it. Then again with pthread join, same as the case with the pthread create. If it returns 0, it means it's a success, or if it returns any negative value, then it is a failure. But we'll be passing null in this lab. Okay, so these are simple 3 lines of code, like how do you include the library, that is pthread.h API library. So just simply hashtag include pthread.h. Then how do you declare a variable of type pthread_t? As you should remember that we used PIDs in the last lab. So here we have pthread. So whenever we declare a variable of type pthread_t, we should use this word instead of int or any other data type. So pthread_t, and then the name of the thread, thread1, thread2, anything. Then when you compile, so previously we used to do gcc, then the name of the file, then dash output, then again the name of the output file. But here we have to use this simple additional linker flag with it, so that the compiler knows that I have to execute threads in this program. So gcc, name of the file, output, name of the output file, and just a simple addition, that is dash lp thread, right? Okay, another side note, it says that threads are created from within a process. Once created, the threads are peers and they can create further threads. Note that initial thread exists by default, and it is the thread which runs the main function. Alright, now how do you get the value of the thread? Like previously we used the PID, that was the process ID, so we used get PID. Here if you want to know the ID of the thread you are executing, so you should use pthread_self, and it will return a unique thread ID of the calling thread. The returned data object is opaque and it cannot be easily inspected or interpreted. So it's not a simple integer, like as in processes, like it is 2020, let's say, and some other integer. It's a very it's a complicated value. We'll cover it later, that how do we inspect it. Then how do you know that if 2 threads are equal? So we cannot use a simple C language equivalence operator, that is equal to. That is because that the thread IDs, as previously mentioned, they are opaque objects. So we have to use this function pthread_equal and just pass thread1 and thread2 to this function. Okay, so now let's go towards the practical implementation. So for to save some time, I've already executed all of these codes and saved it in my folder. So I'll just straight go there and I'll let you know what these are. So the first example is pthread creation and termination. Simple. Okay, first of all, just let's go to the terminal. I have to go to the work directory, sorry, cd work ls operating systems ls. I have to go to lab number 5, so cd lab 5. Okay, so as you can see that I've already made the files. So let's open the first file, that is gedit test.c. Okay, so in this example we have to we will learn that how do we create a thread, and then how do we terminate or how do we wait for a thread. So as as the first step is to include the library, so stdio.h for the C and then pthread.h for the different threads. So whenever you call a thread, you have to call it using a function. Remember this, whenever you create a thread, I must say, whenever you create a thread, you have to create it using a function. You cannot just create it simply in the main. So this is just the function, leave it for the while. First of all, I'll create a a variable of this pthread library, so pthread underscore t, and just give it a name, let's say a kid thread. Then I'll create, simply write pthread underscore create, this is the function included in this library, and I have to pass the thread that I have mentioned before. So and kid, that is passed by reference, and for a time being consider this as null. And which function do we have to call for the creation of the thread? This kid function. So kid function and null. Now this function will be called. When this function will be called, it will print that kid id is get PID. It will get the process ID of this whole process. Then it will print that parent ID is again get PID. Then it will wait for this thread to get executed, and then it will say no more kids. Let's just execute and see what is the output. So gcc test.c-o test and -lp thread. Please do remember this or it will give you an error. Now just run the file test. Okay, let's open the file so we get to know. First of all, it says that it comes here and it creates a thread. So it comes here and it says that kid ID is 3941, that is get PID, that is the process ID. So 3941, then it gets executed and it says that parent ID is get PID, so it's again 3941. So by this and then it says that no more kids. This implies that if you create threads, it will not have any effect on the ID of the process. So it will have the same process ID whether you create one thread or 1,000 threads. That depends on you. So whatever the parent ID is, because the process is the same, you must remember that threads are not processes. They have some other properties rather than processes. So the process ID will always be the same, only the thread ID will be changed. That we'll be covering in the next example. Okay, so now the next example is okay, so it says that are the process ID numbers of parents and child threads the same or different? So it was the same. And why were they same? The reason is because once we create a thread, the process remains the same, but only the threads are created within the process. Okay. The second one is we want to know about the data management in threads. How do we manage data in threads? So how do we use global variables and local variables? So let's have this command running. So okay, so this is the second example. Again, including the libraries. Then I have defined an integer, and it is a global variable. A global variable is the variable that is that can be accessed by any function in the whole code. So if I'm here, or I'm in this function, or I create any other function, I'll be able to have this. I'll be able to get this variable. So this is the global variable. What is a local variable? Local variable, if like I have a variable over here, so I cannot use it in this function. So this is basic programming. You must already have this idea. Anyways, this is the function for that we have written for the process for the thread creation, and we'll start from here. Again, pthread_t, the data type, and then we have created we have named it as a kid thread. Then I'll create, same as before, and kid null. Which function do we have to call on the creation of the thread? That is the kid function. This. So whenever once it is created, it will come here and it will say that kid here, and the global data is, it should be 5. Then this will change it to 15, and it will say kid here again, and the global data is now 15. Then it will come here and it will say that parent here, and the global data is, we will have to see what it will say. Either it will say 5 or it will say 15. We have to check it in the output. Then it changes this global variable to the value of 10, and it waits for the execution. It waits for the termination of this thread, and it says that end of program, and the global data is, we have to check it in the output. So let's first run it, first compile it, test1.c. okay, it doesn't have any errors, just one. Right, let's open the file so we get to know the output. First of all, it creates a thread and it comes here. It says, sorry, okay, the parent executed first. It says parent here, global. Okay, I must confirm one thing here. As in processes, we did not know in which pattern the execution of processes will take place. Child process will be first, or parent processes will be first, or child 2 or child 3 or child 4 will be first. So in the same manner, we do not have any idea how this execution pattern will be. Either the parent, the main function will be called first, or the kid creation will be, the thread creation will be called first. So we do not have any idea about that. Anyways, it says that parent here and the global data is 5. So the global data is 5. Then it says kid here. It has created the thread and it comes here. It says kid here. The global data is 5. Again, simply 5. Then it changes and it says the kid here again, and the global data is now 15. Right? Then this data is changed and it says end of program, and the global data is 15. So just think a little bit over it. What it says, it is because this parent execution is done, and then it changes the global to 10. First of all, it says the global data is 5, then it changes it to 10. Then it waits for this thread to be created. So it has already been changed to 10. So in the meanwhile, this has been created and it says it is 5, then it is changed to 15. So once this is the thread is terminated, it would say end of program, and the global data is 15. So this step is skipped. Let's just run it again. So we check the output again. Okay. Now let's go to the task again. Now this time it says that parent here, the global data is 10. Sorry, the global data is 5. Parent here, the global data is 5. Then it says kid here the global data is 10. Kid here the global data is 10. Previously it said kid here the global data is 5. That was the reason, as I told you, that we do not know what is the pattern of execution of these threads and processes. So either one can get first and the other one can get second. So for this, that I have told you in the start of the lab that we will use mutexes further in our next advanced labs. So mutexes are locks that once one process or thread is executed, after that we will allow the second to be executed. Okay, so now it says that parent data is 5. Then it executes this, and it goes to the function. So it says kid here, and the global data is now 10. Global data is now 10. Then it says kid here, and the global data is 15. It has changed, and at the end it says global data is 15. So this is the difference between two. Here in the previous example, this was executed. Then before this execution, the thread was executed, and we got these outputs. But in the second example, this got executed, this line, then this got executed, and after this the thread was created. It took a little bit more time. So just run this program like 5-10 times and just get to know what about this data management, so you'll have a clear idea. Okay, so what question does it ask? Do the threads have separate copies of global data? No, it does not have separate copy of the global data. So the global data in threads remains the same, so it can be accessed by the main or the threads. Okay, now we have to make or create, I must say, multiple threads. So this simple example code below creates 5 threads with this function. Each thread prints a hello world message and then terminates itself with a call pthread_exit. So let's go to the code. test2.c, I hope so. Yeah. Okay, so libraries. Then we have defined a data type of number threads, and we have told it that the maximum number is 5. So we have to create 5 data. We have to create 5 threads. Okay. The function of the thread. Then we will come to the main. We have created a pthread_t type thread variable having an array of 5. So we have to create 5 threads. Then we have created 2 integers rc and t. Then for 5 threads we'll use a for loop. First, t is equal to 0, t is less than the maximum number, that is 5, and t++. So creating thread. First it will say creating thread and number of the thread. So t is the number. Let's say in the first iteration it would be 0. Then we'll create a thread, same as that, threads and the number of the thread, and null. Then which function do we have to call? That is the print hello for the creation, and void t. The output of this thread is stored in an integer rc. So what we have studied before, if the return value of the function pthread_create is 0, it means that the thread was successfully created. If not, then it sends an error code. So we'll have an if statement just for checking that whether the thread has been created or not. So it will create a thread, a first thread, and it will check if rc, that means if rc is just a short form, it means that if rc is greater than 0. So if rc, it will print error, return code from pthread_created's rc, and it will exit with a negative -1 value. That means an error termination. But if the value is 0, it means that the thread has been successfully created. So it will just go to the second loop, it will create a second thread, and so on. So upon the first loop, it will create a thread for the first, that is threads 0. It will come here, it will say hello, and before hello it would have the thread ID. So hello, the thread ID, and it will terminate itself. Then second, third, fourth, and fifth, and at the end it would again use the pthread_exit function. Let's execute it. Let's see what happens. So 2. Okay, so these are warnings, no error. Let's just clear it up a little bit. So okay, test 2. Let's open the file as well. So first it would say creating thread T, that is 0. So creating thread 0, then it would say creating thread 1, then it would say creating thread 2. What does it imply? It implies that this for loop is faster. In this case, in this current execution, it is faster than the process, the thread creation. So the thread has not yet been created, but the loop was changed. Then the loop was changed, so it says creating thread 0, creating thread 1, creating thread 2. Then it says the first thread says hello world, although the thread 0 was previously created. Then it says creating thread 3, then created thread 4, then the 0 thread says that hello world, then the third, then second, then fourth. Okay, so if I run this code again, then this pattern will be changed. Just check it out. Let's run it again. See, it has been changed. Creating thread 0, creating thread 1, then the number 0 thread says that hello world, then the first thread says that hello world, then creating thread 2. If I run it again, it may get changed again. See, it got changed again. Okay, so now let's just change this code a little bit. Let's call a function of pthread_join. So what would this function do? It will wait for the thread to get created, and then executed, and then terminated, and then it will go to the second loop and it will create another thread. Let's see if it works. I'll just pass the current thread T. I hope that is enough for this. Yeah, okay, so null. Okay, so now let's see what is the output. Let's clear the output, or just first compile the code. So these are warnings. Okay, now let's clear the output. Let's run it. Test 2. So now if I check the code with the output, first it will come here, it will say creating thread 0, then it will create a thread, it will come here, and it will wait for the next thread. So it goes here, hello thread, hello world, by this thread. Then once it has been executed and terminated, then it will go to the second loop and it will wait, then it will go to the second loop and thread creation 1 1. If I run this code again, it will have the same output, most probably. Yeah, it doesn't depend how much times I run this code, but we'll have the same output because I have used a waiting function in the process in the program. Okay, so now in this well, this is the last example. So in this example we'll know about the differences between processes and threads. So this example will be a little bit it will be confusing, but let's understand what's in there. So let's open the program. So in this program we have to know about the difference between the processes and threads. What are the properties of processes and what are the properties of threads in in respect of local and global variables, local and global data, and the IDs, the process IDs and the different addresses. So first of all, the libraries. Then we have written global variable that is integer. This is global. We have not assigned any value to it yet. Then we have defined a function, thread underscore function, for the thread creation. We have used it down here. We have just defined it here and we have used it down there. Okay, so first, integer local main for the local data in this integer function, in this main function. Then two integers, PID and status. Then we have to create two threads, thread 1 and thread 2, using pthread underscore t. So first of all, it will display, first we create two threads to say better what context they share. Then we'll change the value of this global data, that is, this is global is equal to 1000. Then it will say set this is global to 1000. Then we'll create the two threads using the thread function, and we have to wait for the other threads to get executed and terminated. Then it will say that after threads, so okay, so what's in here? So once these threads are created, it will say that thread number this, having the process ID number this, addresses of the local and the global. This is the local and this is the global. Data is this and this. So how do we know the thread ID? It will be known by pthread underscore self, I've already told you. Then the PID, so get PID. Then the address of the global variable, so we have to pass it by reference. So this is global, and again this is the address of the local data. Then the global variable will be incremented by a value 1. Then it will say in thread number this, that is its own self, incremented this global to +1, that is 1000. So it would now be 1001, and this process and this thread will be terminated. Then this thread will be created and then terminated. Then it says after threads, this is the global value. We have to check what the global value is. Then now that threads are done, let's call fork. fork is used for process creation that we have already studied in the last lab. So now we have to study about the processes, so we'll get to know about the difference. So this is the local main, this is a local variable of this main function, it is 17. Then this is global, so its previous value was 1000, then 1001, now it will be changed to 17. So it will say that before fork, then that is the creation of its child process, the local main is 17 and the global main is, and this is global is 17, both are 17. So then a fork is a process is created. So if the PID is equal to 0, that means this is the child, we've already studied it. And if it is greater than 0, it means it is the parent process, and the PID has returned the excuse me, the PID has returned the value of the child. So if it is the parent, it will say in parent my PID is this, and this is the address of the global variable, this is the address of the local variable. But it will say that local main is 17 and this is global is also 17, and once the child process is executed, it will say in child my PID is this, the addresses of local and the global is this and it will change it, the local to 13 and the global to 23, so it would be changed here. So now let's run it first so we get to know the output. Let's exit. Okay, so we'll compile it. These are warnings, alright. Let's clear it and test free. Okay. Alright. Now let's also open the file. Alright. First of all, it would say that we create two threads, then set this this is global to 1000, then the first thread is created, so it will come here and it would say that thread number this. See, it's a very complex opaque object value. My PID is 4151 address of global and local are these are just the addresses. Then this is incremented, this is global is incremented by 1, so again it would say that in the same thread incremented global value is 1001. Then the next thread will be created and it will say this thread number is this. See, it was 96, now it is 92, so it's changed. PID is the same, as I've already told you that PID won't change for threads because it is the same process. Addresses of global and local will also be same because addresses are the same. And then it would say then that in thread this the incremented value is 102. So first this this thread incremented the value by 1, then it waited for the second thread, and again this thread also incremented the value by 1. So then it would say that after threads this is global, so it has been changed to 1002. Now that the threads are done, let's call the fork. Before fork, local main is 17 and this is global is also 17. Before fork, both are 17. Now once it has been created, the child process, so let's see which one is executed first, the child or the parent. Before fork, this, okay, so the parent executed first, so the parent ID is 4151, the addresses of global and local are these, and then the child is executed and the child says this is my ID, these are the local and global variable addresses. See, the global variable are same, 602094, same same here, but the local are changed because in this main function the local is this, the address is this, but in this thread function we have our own local over there, so it would say so this is another local. Anyways, child set local main is equal to 13 and global is equal to 23. See, we have changed it here, and in parent it is same as previous. So that implies that, again I would come to the conclusion that in threads we do the process IDs do not change because it is the same process, only the thread IDs change, only the threads IDs change. You can access global variable from any thread, and the process IDs are only changed in by using fork, that is parent child processes, and the global variable is again accessed by everyone, so you can change it in parent or child. And so I hope this clears a little bit of your confusion. So run this program 2-3 times, let's see what the outputs are, and then do some changes from your own side. Whatever the ambiguities there are in your mind, just change it here, and let's see what the outputs are. So if there is any problem in this lab, please do let me know. I would be glad to solve the problems. In the end of this lab, there are few assignments. Problem number 1, you have to execute this code and answer the question. Then again problem number 2, and then problem number 3. So this was a short lab, but a sort of a different lab. So if there is any problem, please let me know. And prepare well for your examination. I'll also upload your midterm examination that will be conducted after your theory examination, and then we'll have a presentation and viva. So prepare for that. Submit your lab assessments. If there is any issue, you can contact me using my official email address or Google Classroom. So thank you so much. Revise this lab again and again for good understanding, and take care. Allah Hafiz.